Previously in our series, we had a ray tracer. It worked, was nice, had reflections. Something looks a little off about these reflections. They look fine, but a little too perfect. Let's add some random noise to add a little bit of fuzziness, a bit of variation to the reflections. To do this, we'll open up our engine class and we'll just go down here, no, not here, create resource memory. So this was essentially creating a texture to store all of the objects. We will modify a copy of this to create a noise texture. We've got red, green, blue, alpha, and I'm not going to mess around with this. I'm just going to keep the full red, green, blue, alpha. Use the first three components for the X, Y, Z components of our noise. We'll run Y up to the height of the screen. Then we'll run X up to 4 times the width. This will generate 4 screens worth of noise just all stuck together along the X. So here we're just generating X, Y, Z by standard spherical coordinates, and we're adding on a 0 for the W component. That's fine. And yeah, there we are. We've generated that. So now we will just cast this into a NumPy array. Create the noise texture. That all looks fine. Oh, and I missed this before. Our object data was texture unit 1. This will be texture unit 2. Okay, so at this point we have generated that random noise and stuck in there. By the way, I'm generating a collection of random vectors in a unit sphere or within a unit sphere. So when we add this unit sphere vector onto a normal, there will be some kind of natural variation in the normal. Just go ahead and create this. Okay. Then we'll go down to prepare scene. Right down here where we send in the object texture, and we'll also send in the noise texture, making sure that's binding number 2. Okay. At this point, we'll go to our shader for our ray tracer. And right down here, we have objects. Just set this up. Okay, so right down below, we have, where are we? This point here where we are reflecting. So what we'll do is get a bit of variation. Just going to whoops, that's not good. Just going to rename this because what we're doing is we're bouncing the ray. So I'm just going to call that bounce. So this is the bounce index that we're working with. Okay, so pixel coordinates is the coordinate of the pixel on the screen. So every pixel on the screen will have a fixed kind of variation on the bounce. But also the bounce index should be changing each time, just to add a little more randomness to it. So every time the bounce index goes up by 1, we jump over to essentially the next screen of noise that we're looking at. There are 4 screens, 4 bounces. Okay. So now let's, oh yeah, also by the way, we should just be getting the X, Y, Z components of that. And now let's incorporate this randomness. Okay, now we'll just go ahead and run that and see how it looks. By the way, I just flick back to that for a second. Yep, so we just add the variation to the ray direction, normalize it, and yeah. Okay. So it just takes a bit of time to generate the noise, the randomness. And there we have it. But it still looks a little too random. Let's add a roughness parameter to the spheres and the plane to control how tight we want these reflections to be. This is a little too loose. And we'll go to the scene so that when we create these objects, we also give them a roughness value. So as you can see, you can tweak the range here to get a different range of roughness, but I feel this is pretty good. Okay, so now if we go back to the engine, when we create that resource memory, see that we still have space to store the roughness. We don't have to allocate any extra space here. We can pack it in like that. And that will be done in the record function. So we go down to record sphere and record plane, and we can pretty much just slot it in right there. And on the plane. So that's great, we're passing in that information. Now on the shader side, we'll just update our structs so that we can actually take the information. And we're also going to store in the render state. So when a render state hits a surface, we want to know what color we hit, as well as how rough that surface was. Awesome. So now let's go down to the unpack functions. That's unpack sphere and unpack plane. Here we are on the last attribute chunk. And that's the W component of that attribute chunk. So right on the end. And pretty much the same for the sphere. Awesome. So now we'll go to the hit functions. That's hit plane and hit sphere, and we'll record that information. Great. So that is all building up to, where are we? Right up the top. Okay. When we hit, we're going to control this. So we're going to get the render state, roughness, and use that as a multiplier. So if the roughness is very low, if we have 0 roughness, then there is no variation. If we have 1 roughness, then there's 100% variation. Just quickly double checking through that. That should be good, so we'll give it a go. And there we have it. So a little hard to see, but see, it's not completely rough. This purple sphere at the top, for instance, looks a little smoother than this yellow sphere. So now we can control how rough our, what am I going to say? We can control basically how rough our reflections are. That's great. So the last thing I want to do, and this is just another application of noise, is anti-aliasing. So there's actually quite a bit of rejigging we need to do here. But basically, we're going to perform this whole thing 4 times and then average the result. And every single time, we're going to add a little bit of random variation onto the ray so that we're sampling a slightly different thing each time. Just remembering that we should be dividing by the width of the screen in both cases as a normalizing factor. Otherwise, the aspect ratio will be kind of messed up. So what we've done is we've pretty much sampled from our random noise texture, taken XY coordinates and added those on to our screen positions. No worries. And this will be giving us a little bit of random variation each time. Okay, just double checking that. That looks good. So we set the ray up, we shoot. And then we're going to add a quarter of that pixel color. That's essentially averaging them. After that, we will store the final color. So this is the final color averaged over 4 runs. Okay, I think that looks all right. Let's give it a shot. All right, so it's a subtle effect, but these edges around the spheres should be a little smoother. We can actually accentuate it a little bit more by, for instance, multiplying this by 2 would be double the variation. Let's see how that looks. I don't know. Something looks a little off about that. But anyway. All right, so these are some examples of adding noise and using a bit of random noise in our ray tracer. Hopefully you enjoyed that. And yeah, I'll see you in the next one. Bye.